Good morning, champions. So, some champions, how are you? I hope you are gearing for the second term examination. In today's session, we are going to discuss about the hydrocarbons. Hydrocarbons are used in many ways in our day-to-day life. LPG gas is mainly consists of butane. CNG, compressed natural gas, that is mainly consists of methane. Natural gas itself consists of about 90% of methane. We use gasoline, cooking oil, etc. It means lots of compounds are derived from the hydrocarbons directly or indirectly by using them in our day-to-day life. In today's discussion, we are going to discuss on various topics related to the hydrocarbons, and these topics are: first of all, we will try to understand about the hydrocarbon, that is definition, and then we will see how we represent the hydrocarbons, that is representation of hydrocarbons, and thereafter how do we classify hydrocarbons, and then naming alkanes, alkenes and alkynes, as well as differences between the saturated and unsaturated hydrocarbons. So let's begin our class. So hydrocarbons. आजकल एक बड़ा फेमस डायलॉग चल रहा है, थोड़ा मैं भी एक डायलॉग बोल देता हूँ, फिर पढ़ेंगे हम लोग। हाइड्रोकार्बन नाम से इसको हाइड्रोजन कार्बन का कंपाउंड समझा क्या? अगर आप ऐसा समझ रहे हैं तो बिल्कुल सही है। हाइड्रोजन और कार्बन के कंपाउंड को ही हम हाइड्रोकार्बन कहते हैं। सो द कंपाउंड्स ऑफ carbon and hydrogen are called hydrocarbons. Some examples are methane, that is CH4, butane, that is C4H10, ethene, that is C2H4, ethine, that is C2H2, etc. So these are some common and simple hydrocarbons. So the compounds of carbon and hydrogen are called hydrocarbons. As simple as it is, as the name suggests, right? Hydrogen, carbon, hydrocarbon, right? Now we will try to understand how we represent the hydrocarbons, as we represent the other compounds by the molecular formula. In similar manner, we represent the hydrocarbons by the molecular formula, right? We not only represent the hydrocarbons by the molecular formula, but we also represent it by Lewis dot structure. So the representation of hydrocarbons by means of molecular formula Lewis dot structure a structural formula and condensed formula. You know about the molecular formula? A formula representing a molecule of a compound, which also represents the exact number of atoms present in a particular molecule of a compound. So we also represent hydrocarbons by means of molecular formula. Say we represent butane by the molecular formula C4H10. It means It is made up of 4 atoms of carbon and 10 atoms of hydrogen. Lewis dot structure. In Lewis dot structure, we know that hydrocarbons or carbon compounds are covalently bonded compounds. By Lewis dot structure, we represents the sharing of electrons between the carbon atoms and carbon and hydrogen atoms. So, butane has 4 carbon atoms. Each carbon atom has 4 valence electrons. And each hydrogen atom has 1 valence electron that will be shared. So, in this way we can see that the number of atoms shared between hydrogen and carbon is 2. That is, a pair of electrons is shared between hydrogen and carbon. And we also see that a pair of electrons are shared between 2 carbon atoms. So, in this Lewis dot structure, carbon-carbon as well as hydrogen-carbon all are bonded by single covalent bond. So, in this manner, we represent the sharing of electrons between the atoms of a hydrocarbon, and that is called Lewis dot structure. A structural formula, simply we represent the bonding between the carbon and hydrogen by a line. It is simple structural formula. And in condensed formula, right, we just write CS3, CS2, CH2 and again CH3. At both the end, 3 carbon atoms are attached to the carbon compound. So it is CS3, CS3, and between the first and last carbon, it is CH2, CH2. So this formula is called condensed formula. So we represent the hydrocarbons by molecular formula, Lewis dot structure, structural formula, and condensed formula. In higher classes, you will come to know about some more representation, right? But as far as the CBSE syllabus is concerned, knowledge about these kind of formula representation is large enough. Now we will discuss about the classification of hydrocarbons. We are going to see the representation of benzene. Benzene is also a hydrocarbon. The molecular formula of benzene is C6H6. It is called benzene. There are 6 carbon atoms. So first of all, we will represent the carbon atoms. And then we will represent the hydrogen, because the number of hydrogen is equal to the number of hydrogen atoms are equal to the number of carbon atoms. So first of all, we will in representation of benzene Lewis dot structure. We first of all take the 6 carbon atoms and then we attach the 6 hydrogen to each carbon atom. So now there is a sharing of 1 electron of each carbon with the hydrogen atom. And we know that in the hydrocarbons, while we are representing the Lewis dot structure or a structural formula, we have to fulfill the covalency of carbon. That is, the covalency of carbon atom must be fulfilled, right? So, one electron is shared with the hydrogen atom, one electron is shared with the next carbon and with this. It means two of the electrons of each carbon atom is shared with the two neighboring carbon atoms, right? We are now representing the sharing of electrons between the carbon atoms. So each carbon atoms. So we will take this first carbon atom, right? 1, 2, 3. 1 with hydrogen, 1 with this carbon, 1 with this carbon. So 3 electrons are shared, not all 4 electrons. So there must be a double bond between these two carbon atoms. So you can see that 2 to 4, each electrons are shared. 2 electrons of this carbon atom is shared with this, and 1 with this carbon atom, 1 with the hydrogen. So 4 electrons are shared. Now, coming to this carbon atom, 2 electrons of this carbon atom is shared with the first carbon atom, and 1 with the hydrogen, another one with the next carbon. So it is 2, 3, 4. All covalences fulfilled. Now, coming to this carbon atom, one carbon atom is shared with one electron is shared with this carbon atom, one with this hydrogen, one with this carbon, right? So it is the sharing of electron is only 1, 2, 3. So it will also share 2 electrons with the next carbon atom. So there is double covalent bond between these carbon atoms. Similarly, 2, 3 and 4, all covalences are fulfilled and shared. Now coming to this 1, 2, 3, only 3. So there must be double bond between these two atoms. Now if we see all the carbon atoms, the covalence is fulfilled, representing the structural formula. We will show the attachment of hydrogen also by bond line. Double, leaving the next carbon atom, again double, leaving the next carbon atom, again double. So you can see that there is a double covalent bond between these two carbon atoms. So we have represented it by double covalent bond. Leaving the next carbon atom, there is another double covalent bond. So in benzene, there are 3 double covalent bond between the carbon atoms, and hydrogen atoms are linked with the carbon by single covalent bond. The condensed formula, since it is cyclic hydrocarbons, it is represented as CH, CH, again CH, again CH, just like that. In condensed formula, we do not represent the bond line between carbon and hydrogen, right? So these are some examples how we can represent the hydrocarbons and how we can draw the Lewis dot structure of hydrocarbons, right? I hope you understand it. Now, we will discuss about the classification of hydrocarbons. So champions, we are going to discuss about the classification of hydrocarbons. So hydrocarbons are classified as open chain, It is also known as aliphatic as well as closed cyclic or ring. In ring classification, we further divide it as aromatic and alicyclic. In aromatics, we study about the benzene, and its derivatives. And in alicyclic, we study about cycloalkanes, cycloalkenes, and cycloalkynes. So, in cyclic or ring branch, we study about aromatics compounds and alicyclic compound. Aromatic compounds are basically benzene and their derivatives and its derivatives. In alicyclic, we study about cycloalkane, cycloalkenes, and cycloalkynes. Now, coming to the open chain, that is aromatics hydrocarbon, it is further classified as saturated and unsaturated hydrocarbons. In saturated hydrocarbons, the bond between the carbon atoms are bounded by single covalent bond. In unsaturated, carbon atoms are bonded by double or triple covalent bond. These are further classified as alkenes and alkynes, that we will study about all these things separately. So, hydrocarbons are classified as open chain hydrocarbons or aliphatic hydrocarbons, cyclic or ring hydrocarbons. Cyclic and ring hydrocarbons are further classified as aromatic or alicyclic. In aromatic hydrocarbons, we study about the benzene and its derivatives. In alicyclic, we study about cycloalkanes, cycloalkenes, and cycloalkynes, right? Now, coming to the open chain, that is aliphatic hydrocarbon, we study about it is further classified as saturated and unsaturated hydrocarbons. In saturated hydrocarbons, the bond between the carbon atom is single covalent bond, right? It means the carbon atoms are singly bonded. In unsaturated hydrocarbons, the carbon atoms are either bonded by double covalent bond or triple covalent bond. Okay. Now, it is not our concern. As per the CBSE syllabus, you do not have to study about aromatics and alicyclic. You have just have to see a few examples. We have seen the structure of benzene and cyclohexane, etc. But this is not the part of our syllabus, right? This part is in our syllabus. So we will discuss about the saturated and unsaturated hydrocarbons in detail. Now we will discuss about the saturated and unsaturated hydrocarbons. So first one is saturated the hydrocarbons containing single CC bond are called saturated hydrocarbons. For example, methane, ethane, butane, etc. The saturated hydrocarbons are called alkanes. So, the saturated hydrocarbons, the hydrocarbons containing single CC covalent bond are called saturated hydrocarbons. For example, methane, ethane, and butane, etc. We will see how we will name and how we can create the group of alkanes. The saturated hydrocarbons, that means the hydrocarbons containing single CC covalent bond, are called alkanes. Alkanes are represented by a general formula. These are very famous formulas, you might be aware about it. It is CnH2n plus 2. Where N is the number of carbon atoms present in the particular alkane, right? So we will take some example how this formula works. So if we take C1, that is number of carbon atom is 1, then it will be Cn1, that is C1. 1 into 2 plus 2, that is H4, CH4. So we do not write 1. So that is CH4, that is methane. Again, when the number of carbon atoms is 2 or 2, it becomes C2 because we are taking 2 instead of N. C2, and then H will be 2 2s are 4. The number of H will be 2 2s are 4 plus 2, that is H6. When the number of carbon atoms are 3, then it is C3, 3 2 just 6 plus 2, that is 8. And then 4, we have seen the structure of this, that is butane. It is C4H10. C4 for 2 is 8 plus 2, and so on. You can write the molecular formula of number of alkanes depending upon how many numbers of carbon atoms are present in it, right? On this particular formula. Now, we will discuss about the unsaturated hydrocarbons. Now, we are going to discuss about the unsaturated hydrocarbons. So, these are the hydrocarbons containing at least one double CC or triple CC bond are called unsaturated hydrocarbons. So these are the hydrocarbons that must contain at least one. It may contain more than one double covalent bond between the carbon atoms, but the condition is it must contain at least one double covalently bonded carbon atoms or bonded by triple covalent bond. So that is the basic criteria of identifying the unsaturated hydrocarbons. Now, unsaturated hydrocarbons are further classified as there are two types. These are further classified as first one alkenes and second one is alkynes. Alkenes are the hydrocarbons. These are the hydrocarbons containing double covalently bonded carbon atoms. So these are the hydrocarbons containing double CC covalent bond, and alkynes, these are hydrocarbons containing triple carbon-carbon covalent bond. Right? So, unsaturated hydrocarbons, the hydrocarbons containing at least one double or triple covalent bond. So these are called unsaturated hydrocarbons. Unsaturated hydrocarbons are further classified as alkenes. These are the unsaturated hydrocarbons containing double CC covalent bond, that is bond between the carbon atoms. And alkynes, these are the hydrocarbons containing triple covalent bond between the carbon atoms. These two are also represented by the general formula. So the general formula for alkenes is CN H2N, and the general formula for alkynes Cn is 2n minus 2. So these are the general formula for alkenes and alkynes, right? Containing only one double bond, right? With only double bond or only one triple bond between two carbon atoms, not more than that. So these are the general formula for general hydrocarbons containing only one double or triple covalent bond. Okay, so using these formulas, you can write the molecular formula of alkenes and alkynes. For example, when N is 1, that is number of carbon atom 1, we are seeing some examples. When C, that means number of carbon atom is 1, that is C1, right? And H2N, it is not possible. Why? Because These are unsaturated hydrocarbons, and there must be at least one covalent bond, double covalent bond between two carbon atoms. So here is when we take a number of carbon atom as one, right? It is not possible to form a covalent bond with another carbon atom. So for C1, no alkenes are possible. Is possible. So when the carbon atom is 2, put 2 instead of at the place of N, you get C2, and then H2 2s are 4, H4. It is ethene. When the number of carbon atom is 3, R3, it is C3, 3 2s are 6, H6. It is propene. Similarly, the member of this group, that is alkynes, start with 2 carbon atoms. Why? Because there must be at least one triple covalent bond between 2 carbon atoms, so it also starts from second. So when the number of carbon atoms is 2, the formula is C2, and 2 2s are 4 minus 2, that is 2, so H2. It is ethane. When the number of carbon atoms are 3, it is C3. Again, 3 2s are 6 minus 2, that is H4. It is propane. So in this way, you can write the molecular formula, right, of these unsaturated hydrocarbons using these general formulas, right? Now we will discuss about naming alkanes, alkenes, and alkynes. To name the alkanes, alkenes, and alkynes, we require 3 things. That is root word, used as prefix, and suffix. Suffix for alkane, the suffix is A and E. For alkenes, suffix is E and E. For alkynes, the suffix used is Y and E. So these suffix and the root word as prefix are used in combination to name alkanes, alkenes, and alkynes. Now, you must learn the root words. For carbon number 1, C1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We use root words as for 1 carbon atom we use meth. For 2 we use eth. For 3 we use prop. For 4 we use but. 5 pent. For 6 hex. For 7 hept. For 8 oct. For 9 non. For 10 dic. For 11 undic. For 12 it's didic. For 13 it's tridic. For 14 it is tetra, dic, and so on. So while naming alkanes, alkenes, and alkynes, we use these root words as prefix, and ane for alkane, ene for alkenes and YNE for alkynes as suffix, right? So suppose we are going to name the saturated hydrocarbon, that is alkanes containing 6 carbon atoms. So for 6 it is hex. So for alkane it is root word plus ANE. So for 6 carbon atom, when the number of carbon atom is 6, root word is hex and the suffix used is ANE. So it is hexane. Similarly, for number of carbon atom 5, for 5 the root word is pent. So we take pent as prefix and we add ANE as suffix, it becomes pentane. So in the similar manner, alkenes and alkynes are also named. Root word plus suffix. Root words are used as prefix and ANE for alkane, suffix is used, AENE for alkene. Take some examples of alkene and alkynes also. For alkyne, root word plus E and E. When the number of carbon atom is 3, the root word is prop. And add E and E as suffix, it becomes propene. Similarly, alkynes are named as root word plus YNE. When number of carbon atoms are 4, the root word is but plus YNE, it is butane. So in this way, we used to name the alkanes, alkenes and alkynes using root word as prefix and ANE, ENE and YNE as suffix. Now you can write, try to write or practice at least names of alkanes, alkenes and alkynes up to 8 carbon atoms, right? Now we have arrived to today's last topic, that is differentiation between saturated and unsaturated hydrocarbons. So we will differentiate between them. Saturated hydrocarbons and unsaturated. So the first difference is they contain single CC bond. They contain double or triple CC bond. There is the major difference, right? Not only between the hydrocarbons but organic compounds, all carbon compounds which are studied in organic chemistry, saturated, unsaturated. Now the second one, they are less reactive. And hence more stable. They are more reactive. And hence are more reactive. and hence are less stable. So saturated hydrocarbons are less reactive, but they are more stable. Unsaturated hydrocarbons are more reactive, but they are less stable. We have discussed about the stability of bond, right? Single covalent bond is more stable as compared to the double and triple covalent bond. So saturated hydrocarbons contain single CC bond, so they are more stable, and the compounds which are more stable, less reactive. Whereas unsaturated hydrocarbons contain double and triple bond, so the bond strength is weak, hence they are more reactive. They do not went under Addison reaction. Whereas unsaturated hydrocarbons, they went under Addison reaction. Now we will try to understand about the Addison reaction. A kind of reaction in which other atoms are attached without replacing any of the hydrogen of hydrocarbon. That reaction is called Addison reaction. So in saturated hydrocarbons, it is not possible to add any other atom of any other element without replacing hydrogen. So they do not went under Addison reaction, whereas in saturated hydrocarbons, because of the presence of double and triple covalent bond, it is possible to add new atom without replacing hydrogen. That's why saturated hydrocarbons do not went under the Addison reaction. Unsaturated hydrocarbons went under the Addison reaction. Saturated hydrocarbons, they burn with blue flame and do not produce soot, whereas unsaturated hydrocarbons, they burn with yellow flame and produce soot. So we can say that hydrocarbons do not produce black marks. Saturated hydrocarbons do not produce black marks over the utensils when they are burned, whereas saturated hydrocarbons produce black marks, that is soot, right, on the utensils. So we can say that saturated hydrocarbons are clean fuel as compared to the unsaturated hydrocarbons. So these are few differences between the saturated and unsaturated hydrocarbons. Let us recap. The differences between saturated and unsaturated hydrocarbons are: saturated hydrocarbons, they contain single CC bond, whereas unsaturated hydrocarbons contains double and triple CC bond. They are less reactive, that is saturated hydrocarbons are less reactive, hence they are more stable. Whereas unsaturated hydrocarbons are more reactive and hence they are less stable. Saturated hydrocarbons do not bend under Addison reaction because of the presence of single covalently bonded carbon atoms, whereas unsaturated hydrocarbons went under Addison reaction due to the presence of double and triple bond. They bond with the blue flame, right? They are considered to be the, that's why we use butane in LPG. They bond with the blue flame and do not produce soot. They do not blacken, right, the bottom of the utensil that we use for cooking. They bond with the yellow flame and produce soot, right? So what we have discussed today, we have discussed the definition of hydrocarbon, the representation, classification, naming alkanes, alkenes and alkynes, and differences between the saturated and unsaturated hydrocarbon. At last, one more thing. Today the internet is flooded with the motivational quotations, speeches, etc. But dear students, The motivations come from within, right? Try to find within yourself though that thing that motivates you a lot, that will motivate you for a long period of time rather than watching videos, etc., isn't it? Because when you are receiving the motivation from outside, it motivates you for a short period of time. But when you get the motivation from inside, that is something which is in you that motivates you for a long period of time. I hope these topics are very clear to all of you. Thank you very much.